right, let's go ahead and start. Today we're doing the quiz on Chapter 10, and then we're going to learn 11.1, the goodness of fit test, the chi-squared goodness of fit test. Due today, you have My Math 10.1 due today. On Wednesday, you'll have 10.2 due, so in a couple days. Next Monday, you'll have 11.1 due, and then next Wednesday, 11.2 due, and then the following Monday, you'll have 11.3 due because our final will be Wednesday, May 24th. And technically, it's at 5:30, but I think we should go ahead and start it at 5. That way, we have a little bit extra half-hour cushion between when the next final starts, and that will give you folks a little more time I can give you a little bit of bonus time if you need it. Okay. The final exam is going to be the final exam and exam 4 together. Right? So you have this exam, it's worth 24 points. About a fourth of that is going to be exam 4. The rest of it is going to be the final, which is cumulative. So it means that 25% that's exam 4 plus another 10% of the final is going to be exam 4 material. So exam 4 material will make up 35% of that exam. And then the rest of it, about 20%, will be on exam 1 material, 20% on exam 2 material, roughly, and 25% on exam 3 material. If you have borrowed a TI-84 from the library, you can turn it in after the final. That's fine. Again, don't miss this week, because we're going to cover half of Chapter 11 today, the rest of Chapter 11 on Wednesday. So missing this week is just a really bad idea. Because getting it here and getting it in person is just so much more beneficial. Next week we're going to do review. So next Monday we'll review all of exam 1 and part of exam 2. And then Wednesday we'll kind of review the rest of exam 2 and exam 3 and whatever, the later stuff. And then if you want to a review session, I will do one for you folks. I might change this. Are you folks okay if I make this later and do it from like 5:30 to 7:15 or something like that? Would that be all right?
What's May 22nd? A Monday or Wednesday?
It's a Monday.
It's a Monday.
Yeah.
And you want to move it more down?
Half an hour later. I think I might do that because it kind of matches up. And some people work, so they have time. It's a little bit easier to get here from. So I think we'll change that, and we'll make that 5:30 to 7:15. So that kind of matches up with when we're here at the end part of when we're here. Okay, good. Though honestly, I'm not sure how much you folks are going to need it because we're going to do a lot of review next week. So we'll see. You folks may be like, forget it. We don't want to come. But yeah, we'll play it by ear. If exam 3 did not go well, they're all graded. The scores are in Canvas. If it didn't go well, don't forget that or if any of your exams did not go well, your lowest exam, I can average that with your final exam grade if that helps that exam grade. So for example, you messed up exam 2, had a bad day, stuff was going, your dog died, whatever, right? You got a 40%, and then the final exam you get an 80%. Then exam 2 will change to 60%, and the final exam will stay like it is. Right? So just, and I can do that because the final is cumulative. So that is, sort of an acceptable thing to do. So make sure you do well that you study hard, study well, smartly for the final. I would say start preparing for the final now. Do you folks want the exam 4 study guide? I better hand out next class because you don't have everything yet on it. So
most of it, I mean the beginning stuff, we could do that first.
Okay,
bit, right?
so yeah, so what I will do is let me search through this and try to find the study guide for that. I'll pull that up in a little bit. Because the study guide is basically specific problems from the past study guides, so I can give that to you today. That's not a problem. All right, so how about strong reader? Michael? Go ahead.
You worked hard, don't blow it now.
The top part too.
Wait, what?
Focus.
Oh, focus for 2 more weeks. You've worked hard, don't blow it now. Finalists 24% of your grade, keep up homework 18%, participation is 15%, tech lab / discussion is 7%, each exam is 12%, and the final is 24%. Your grade is calculated as a weighted mean similar to probability distribution or GPA. See bottom of Canvas homepage for link to calculate options.
Right. So what that means is, if you go to Canvas, here is your Canvas site. You go to the very bottom page. There is that link I showed you folks last time. Here, I'll show it to you again. It's this one right here, computer grade, right? It's just a Google Sheet. You can type in what your grade is and different things to see what you can. Do you get this person apparently did really, really well so far, so they can get 50% on the final, and they can still get an A in the class. So it takes some of the pressure off. But again, getting 50% on the final doesn't mean that you cannot study for the final and get a 50%. Even if you did well in previous ones, because it's been a while, people forget stuff, and if you don't prepare for it, then you can blow the final. And I've had people who are getting, like I said, I talked about that student, right, who's getting B's all the way. They kind of blew off the final and they're getting like a 30-something%. And it totally screwed up their grade, right, because they didn't prepare. They're like, oh, I got this, and they didn't prepare. Right, so do some, preparation for that. And actually attending next week is probably the best preparation you can do for the final, and doing the study guide problems, which I'll give you folks in a little bit. While we're here, I did want to see, let's see if I have it here. Modules. Module 4 is here. Exam 4 and final study guide. So here's the exam 4 practice exam solutions. Nope, I don't have that list. Okay, I will try to get a list up of which problems you should be looking at. Oh, I thought this was great. This is a great quote that I ran across last year. Let's go to Good Reader. Laura, go ahead.
We are socialized to see what is wrong, missing off the tear down the ideas of others and uplift our own. To a certain degree, our entire future may depend on learning to listen. Listen without assumption or defenses. By Andrew Maru Brown.
Right. So a lot of times it's like we're art and society. We focus on who's to blame, what's wrong, what's missing, right? And we kind of look at trying to find ways of like proving people that you're wrong, I'm right. And that's kind of the that's kind of attitude people tend to have. Kind of the my way is the right way. Why are you doing it that way, sort of thing. And we. If we can kind of get away from that and kind of listen to other people's ideas and kind of consider the fact that our assumptions may not be correct, right? Then that would go a long way to making society just better in general. So something to think about since you are the future. Oh, this is kind of cool. All right, so this thing's super corny. It's this mantra that a student of mine, she was totally stressed out. She had a tough time passing this class. She took it like 3 or 4 times. But at the end, she pulled everything together and she really did well and she did great. And what she would do is she had total major math anxiety. She was never strong in math, right? And she would play this in Tracy on her way to exam and to midterms. And so for that half-hour drive, she just hear this guy saying over and over again, "You can do this. You prepared for this. You've got this. You're capable, right?" And sort of, and she kind of got to the spot where she could say it with him because she knew it well. And she said it's kind of corny, but it totally worked for her. Because just hearing yourself and saying it and hearing it, she'd go from being totally stressed out to being calm at the exam, and then she could do well on the exam. She could show what she did know. So I don't know if I can. I don't think I can hit the link to it. It doesn't seem like. No worries. It's all good. Anyway, so it's there. You can check it out if you want, or you can Google your own. Right? Just it's mantras, kind of math anxiety mantra might work, or something like that, or test anxiety mantra. All right. So let's take a look at chapter 10.1. Mustafa, go to read.
Correlation determines if a linear relationship between variables exists. Regression describes the relationship between variables. That is positive or negative, linear or non-linear.
Perfect. Sophia? Oh, wait. Yeah. These are the questions we're looking at.
Review chapter 10. The purpose of this chapter is to answer these questions statistically. Number 1, are two variables related? Number 2, if so, what's the strength of the relationship? Number 3, what type of relationship exists? And number 4, what kind of predictions can be made from the relationship?
Perfect. Then we have scatter plots, right, which we talked about last class. You folks did one. It's a graph of the ordered pairs, x comma y, because correlation regression is all about these ordered pairs, x comma y. And in this, and you folks have done that many times. Remember x, if you just draw a number line, you draw it like this, right? If you're just drawing a number line, that's your x-axis. That's the first one. That's the first number. It tells you where along here to go. The second one tells you how high to go. And typically, we're just going to work in where we have our x's and y's are mostly positive, because usually it's things like time or number of objects, and you can't have negative trees. You can't have negative 10 trees. You can't have negative time. So usually we're only working in this first quadrant, where both things are positive. It's important to graph it. You will have a homework question where it will ask you, you'll have to sort of graph the points. In your calculator, you can graph them, and have I shown you how to do that? You might need to do that. So I'll show you that in a minute. But has anyone got to the homework where they have outliers yet? So the outliers, what you want to do is you want to graph them. And we'll go through one of those. And give me a second. I'll pull it up for you. All right. So let's take a look. Let's get Quentin. Go ahead and read.
The population correlation coefficient denoted by
A rho. That's rho. R-H-O.
rho is computed by using all possible pairs of data values x, y taken from the population.
Right, and that's kind of like a P, but it's not a P. It kind of loops around. It's not a notch like that. It just kind of loops around. Rho, R-H-O. Keep going.
The linear correlation coefficient denoted by R is computed from the sample data and measures the strength and direction of the linear relationship between two quantitative variables.
Good. All right, so again, we're looking at correlation coefficients. R is the one for the sample. That's the one that you folks are going to be computing. We can actually compute from the sample, and we use that to predict what rho is for the whole population. The correlation coefficient. Isaiah, go ahead and read. Okay.
Correlation. The range of the correlation coefficient is from -1 to +1. If there is a strong positive linear relationship between the variables, the value of R will be close to +1. If there is a strong negative linear relationship between the variables, the value of R will be close to -1.
Exactly. So again, this is a very strong, this is a perfect line with a positive slope. This is a perfect line with a negative slope. And this is just a big circle with random dots, right? Just a blob where there's no correlation at all. They're just scattered. So over here, your data is going to form a positive line, right? Here it makes and that sort of looks like a 1. Those sort of look like 1s. And then this one here, if you think about it, it just looks like a bunch of random dots. Just like a big ball. So the nice thing about that is that sort of looks like a 1, that sort of looks like a 1, and that looks sort of like a 0, right? So it's kind of a good way of turning on that one. All right, so with your neighbors, go ahead. Try this on your own first. So give yourself 1 minute on your own, and then I'll let you check in with your neighbors. Try to figure out which of those numbers go with which of those values. Okay, so which one is 100? Which is 100? None. R goes from 0 to 1, so -1 to 1. So all of these do not exist. Everybody good with that part? Perfect line is, when the positive slope is 1. Perfect line with the negative slope is -1. This one over here on the 0. And then these two are going to be something positive that's between 0 and 1. Right, so that's 0.6 and 0.8. This one's closer to 1, so that's going to be 0.8. This one's not as close of a much of a line, so that's 0.6. And then these two are the two negative sloped ones between 0 and -1. This one's closer to a line, so it's going to be -0.8, because it's closer to -1. This one will be -0.5. Okay? No. So, which one's closer to a line? This one. A perfect line would be -1. So which is closer to -1? -0.8 or -0.5? -0.8. Right, because it's going to, this is, here's 0, -0.5, -0.8, -1. Yeah, good question. Thank you for asking that.
I think I was thinking like which one's closer to 0.
Yeah.
And I was like, yeah.
Right. So think of which one's closer to 0, and that should be the bigger one. Is that sort of the more fluffy one? Right. So this is closer to 0, so it should be more fluffy in a sense. Fluffy, maybe isn't a good word for it. I don't know. All right. Widespread. There you go. Correlation coefficient R. There is that big formula, which we did last class, just so you get a sense of the work that could be involved in it, and also to show what your calculator can do with lists. We are not going to use that. We don't need that anymore. Instead, we're just going to use stat test linear regression t-test of L1, comma L2, frequency 1. And again, we need 3 sig figs. So 3 sig figs on the exam. I did not always get 3 sig figs, so make sure you give me 3 sig figs at least. 4 is okay too, but 3 at least. All right. For our step 1, we have our H0 and we have our H1. In this case, H0 is always no. H sub 0, right? So it means 0 something. In this case, 0 correlation. No correlation. Not a line. No correlation, no line. Which means that rho is equal to 0. That's when it's not correlated, right? H1 then would be the opposite of that. Rho is not equal to 0. It's close to -1 or it's close to +1. So then it is a line. And you can either write it with that weird symbol rho, or you can spell it out, RHO. I'm fine with either one. Do not give me P though. P is a proportion. Good? Everybody over there heard me? No P's. It's got to be rho, or it loops around like that, or just spell it out, RHO. Okay. So here are your steps. All right, write down your hypotheses. Step 2, 4, and 5 are the same as they have been in the past. Step 3 is different. It's just linear regression t-test instead of t-test or one prop t-test. And then also make sure that you note, it might be helpful for you to note for yourself that when you reject H0, it is a line. If you do not reject H0, it's not a line. Does that make sense? So not reject, not a line. And that's sort of I'd find that helpful myself. So if we do not reject H0, that means it's not a line. I'm getting nods, that's helpful. All right, let's take a look. So here's the very first one. And I'll just call people to give me steps. Taylor, step 1, what'd you get?
H0 is rho is equal to 0.
Rho is equal to 0.
And H1 is rho is not equal to 0.
Great. Rho is not equal to 0. Perfect. Terrific. Step 2, Devin,
Alpha equals 0.5.
alpha equals 0.05.
05, yeah.
Good. Mustafa, step 3.
R equals 0.940.
Oh, how'd you get that though?
Line reg t-test.
Okay, great. Linear regression t-test of L1, L2, 1, and not equal to. Okay, and so then you had R equals what?
R equals 0.9409.
409.
P
Okay.
equals 5.1409.
5.14.
E negatives.
Okay, great. So this is 514%. 514% seems kind of incorrect, right? So what's up with that? Anytime your probability is greater than 1 or 100%, then you better have a what at the end? E negative. In this case, you had an E negative what?
6.
E negative 6. That means you write 6 zeros, then your 514, and your decimal place goes after the first 0, like that. Okay, good. Mustafa, can you give me the A and the B while you're at it?
A equals 0.0193.
0.0193.
B equals 0.6371.
6371. Okay, everybody else got the same thing?
You said you want 4 sig figs, right?
At least 3.
Okay.
Yeah, 4 is good, but I need at least 3. Quentin, did you get to step 4 yet? Yeah, I'll come back to you. Shauna, what do you get for step 4?
P is less than alpha, so
PV
yes.
is less than alpha. Yep.
So we reject H naught.
Reject H naught. All right, so then is it a line or is it not a line? Check with your neighbors. 10 seconds, go.
So,
Is it a line or not a line, folks?
It is
a line.
It is a line. It's a line. Okay, perfect. And then our last step, Aaron?
Would be enough evidence to say correlation between, and then like the statements would be the percentage of a certain drug in the bloodstream.
Perfect. Say correlation.
Correlation between the percentage of a certain drug.
Drug percentage. I'm just going to paraphrase because I'm lazy. Drug percent and
In the
Reaction time?
bloodstream. Or,
I'm just looking at the labels up here. Reaction time.
yeah, reaction time.
Reaction time. Good. Perfect. All right. Now, the last thing is the prediction. The last thing said to predict. Oh, wait. Sorry, we haven't gotten there yet. No worries. We'll come back to that. Good. So that is the test. Now we're going to take a look at regression. Regression, again, is the line, the line that best fits this data. And where is it? And find that line, the equation line that best fits the data. And how do they find that? They take the line and they compute the distance, the y distance straight up or down to the line, and then they square all those distances and add them up. It's called the sum of the least squares. So in other words, the line that has the smallest sum of squares is what they call the regression line. Line that best fit. So, Michael, go ahead.
regression line, this line is used to predict the values of y for a given x, only used when there's a correlation / relationship. Rejected h naught, small p value. When rho is not
When R, yeah.
oh,
R.
when r is not significantly different from 0, the best predictor of y is the mean of the data values of y. If not a line, use the average y. Note, if you do not reject h naught, then it is not a line.
Right. So if it's not, if your data is not aligned, it's not kind of in a line, then yes, they'll give you a line, but it doesn't make sense to use the line to predict. If your data is random, don't use that line they give you. Instead, your best prediction is the average y, if it's not correlated. How do you find the average y, by the way? So y equals y bar is what we call the average y, right? Or x equals x bar if they ask you for x. And you find that by doing stat calc 2 bar stats of L1, L2. And here you should leave the frequency blank.
Isn't that like a formula for it then?
Well, you could add up all the y's and divide by how many there are.
Oh. Yeah.
But why would you bother? I mean, you all know how to find the average of something, add them up, divide by how many there are. You already have it in a list though. Why not be lazy and just let the calculator give it to you, right? Because we're well past all that stuff in chapter 3. No need to do that. Quick reminder, right? So you can see both these two have no correlation whatsoever, right? The top one, that the linear regression line is that black line that has a positive slope going up. Here, it has a negative slope going down. Doesn't make sense to use that to predict because it's going to be really messed up if you're way out here. It's going to give you, different, very different answers. So instead, you should just always use the average, the red line instead. Just use the average for everything. That's your best predictor for everything. How do you find this regression line? It's y equals a plus bx. It's on your calculator. They call it y prime. I used to think of it as y myself. And again, x is your explanatory variable, your independent variable. Y is your response variable. And how do you find a and b? Linear regression t-test. So for this part here, what did we say that? Okay, so here we rejected h naught, so we said it is a line, yes, which means that we should use the line to predict. So y equals a plus bx, where a is, I forgot what a was. Someone give me a again.
0.0193.
0193, and b is
0.6371.
great. So you're just going to plug in a in for a and b in for b. So then you'll end up getting y equals 0.0193 plus 0.63371x. All I've done was, instead of writing A, I'm going to write what A is equal to. Instead of writing B, I'm going to write what B is equal to. That's the equation of the regression line. Right here. We'll use that to predict. So everybody, use that to predict for 5.2% of drug. So 5.2% of drug, is that my X or my Y?
Your X.
It's my X. That means that, right, that's the amount of drug. So it means that I'm going to put that in, substitute that in for my X, and then solve for Y. Don't convert that. When it says 5.2%, the percent is the label. These are all percents already. So don't convert it to 0.052. It's already in what it's supposed to be. So just leave it as 5.2. Everybody find that if you haven't found it yet. Do it now, please. Okay, Quentin, tell me what you did to find this. Quentin, what did you do to find this?
Plugged in 5.2 for x.
Yep, put this in for x. So you ended up with y equals 0.0193 plus 0.6371 times 5.2. Great. And then you end up getting, what did you get for your answer? oops,
3.33.
3.33. Good, everybody on board?
Mhm.
And then you should label that one. What is it? Is it amount of drug or is it reaction time?
Yeah.
That's reaction.
So it should be seconds. Everybody got that?
Mhm.
Label it, label it. All right. Now, here's number 2. I'm going to give people, let's say 7 minutes. I will give you folks 9 minutes to finish this, so it takes us to 6 o'clock. If you've already finished it, then take your 10-minute break then, so we'll start back at 6:10. Does that seem reasonable? Or how far are people done with this? How far in are people with this? You finished it? So I'll give you folks, what if I give you folks 5 minutes to finish this, and then we'll take a 10-minute break. So we'll come back in 15 minutes, we'll come back at 6:06. That way we get out of here on time. Yeah.
Yeah.